Hello guys, it's been a long time since I've actually made a video. Today's video is just a past paper walkthrough video. This is for the subject of physics. So I know many of you guys have this exam coming up for exams, so hopefully this video has helped you all to understand these kinds of concepts much more better. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And let's start with the paper. This is a Pearson EdXL International Advanced Level paper. The time for this paper is 1 hour. It's a 1 hour 45-minute paper, and it's on the topics of thermodynamics, radiation, oscillation, and cosmology. All right. So what you must have a scientific calculator, a ruler. They give the total marks for this paper. Okay. So the total marks for this paper is about 90. Use black ink pen. Remember, for your exams, do use black font. It's very important that you use black ink pens in this paper. Center number, candidate number, answer all the questions, and include all the units. All right. So yeah, I think we can start with the paper. This is this is a Jan 2022 paper. So let's start the video. All right. Okay. So section A. Usually section A is multiple choice questions. So we're just going to do a walkthrough for these questions. So the first question is asking, a mass oscillates with simple harmonic motion about a fixed point O. Which of the following statements about the motion of mass is correct? So as you guys can see, the first answer would be it'll be its acceleration is always towards O. Okay, so now we need to know the reasoning why we're choosing this answer. Why can't it be A, C, or D? Okay, so what option A is talking about, it's saying that its velocity is always towards O. Now, this is a simple harmonic question, motion type question, and we're supposed to know some facts about simple harmonic motion. And in one of the definitions of simple harmonic motion is that its acceleration is always directed towards the origin point of the simple harmonic motion. Hopefully I'm using the definition right, but the second point, the second choice answer is related to the definition of simple harmonic motion. So that makes choice B correct. Its acceleration is always towards O. So that's how you get 1 mark for this. All right, let's move on to question number 2. Question number 2 is asking us, in an experiment to determine the specific latent heat of vaporization of water, LV, a student used an electrical heater to boil water in a beaker. Now, the experimental data give LV to be about 2.20 millijoules per kilogram. The textbook value is given to us. Which of the following could be an explanation for this difference in the values of LV? Now, this is more like an analysis type question. So what you're going to do for this in order to score this 1 mark is that look at the choices given to you. Some energy is transferred to the surroundings. You're given other choices. Now, remember, this video is just a walkthrough video, and you guys can also look at the mark scheme answers. It's also there, so these are some of the answers provided for their explanation. I'll just try my best explaining them. Okay, right. So first point is saying that some energy is transferred to the surroundings. Now that point's not right, because the reasoning would be is because as this would increase the value of LV. Now, if you take and look at this question in terms of a scientific point of view, how would you explain this? Is that we would use an understanding of, let's see, the experimental data is given to us 2.20, textbook value is given to you as 2.26. Now there's a difference in these values. So it's probably not because of energy and not of stirring the water, since these are not related to the changes in these values, because it's not necessary to stir boiling water, just as pointed out in part C. And in part D, the inefficiency of a heater is not going to it's going to affect the value of LV, but it's not the reason why there's a difference in this. So the main reason would be the heat power was underestimated. Okay, hopefully they give a good reasoning on why that is. All right, let's move on to the next part. Okay, question 3. So for question 3, I just put some of my working on this. So hopefully you guys can understand what I wrote here. Okay, so question 3, what's it asking? In the Pantheon in Paris, there's a pendulum that takes 8.25 seconds to swing from one extreme position to the other. Which of the following expressions gives the length of the pendulum? Okay, now what I like to do is when trying to solve physics questions, it's always important to write what's given to you. Here in the question, it's given to you time, which is 8.25 seconds. So that's what we have written on the top right there. Hopefully you guys can see that. Time is equivalent to 8.25 seconds. Okay? Actually, you know what? I probably should bring out the pen so I can show you guys while explaining it. Okay? Alright, so what's shown here? Time. Time is given to us as 8.25 seconds. But that's a time from this part. Remember, in a pendulum, when the motion is swung, it's going from one extreme position to another extreme position. So it's more like a to and fro motion. So when we're talking about the time, we're talking about like one oscillation. So you got to multiply that by 2. So you're going to do time is equivalent to 8.25 seconds. And you're going to multiply it by 2, which is going to give you 16.5 seconds. Now over here, I've just written down the definition for what formula we'll be using in this. Remember, you'll be given the formula sheet in your exams, so remember to check that thoroughly. Okay, so what's this given to you? Time. Time is equivalent to 2 pi square root L by G. Now what is L? L is the length of the pendulum swing. Now I'm not talking about half of it, I'm talking about the full thing. From one extreme position to the other extreme position, alright? Many people tend to mistake that with just one part of it, okay? So, and what is G? G is the strength of gravity on the planet on which the pendulum is set up, okay? Most probably they'll just use, the gravity, 9.81 units per kilograms. That's why I've written that down there as well, so you can use that, okay? So now, what do? They're asking you to give the expression for the length of the pendulum. You're given the value of time. All you need to do is just rearrange the formula and find out what L is. Okay, so what I've done here is I've just rearranged the formula, as you guys can see. Just rearrange the formula, and then what you do is just substitute all the values in. That's what I've done here. Substitute time, 16.5 divided by 2 pi squared multiplied by G, which is 9.81. That should give you your length, which is 68 meters. Okay? Now, sometimes in multiple choices, they tend to not give the final value, so you can manually check these in calculators, but in terms of speed of time, hopefully you guys know what you're doing when solving these type of questions. So you just look at this part. You don't need to compute it unless you want to double check that, but just solve it and find it, rearrange it, sub in the values, and just quickly choose that multiple choice point in order to score those points, okay? Now over here, I've just written down some definitions on what the oscillation is, because that fundamental understanding is very important to solve this pendulum type question. So I'm just going to read it out quickly, is that one oscillation of a simple pendulum is just one complete cycle of swinging one way and then returning to its original starting position. In other words, when the to and fro motion of the bob starts from one end, comes back to the same position, it is known as one oscillation of a pendulum. So now what I'm talking about is that the one oscillation of the pendulum is just 2 swings, okay? It's a to and fro motion. Just remember that. Hopefully you guys are taking some notes here, so hopefully it's working. Okay, let's move on to question number 4. Again, I always, it's very important to write down the formulas. I like writing down the formulas so I can see what I can put into that equation and solve it, okay? Remember, very important, write down the formulas, okay? This question's for 1 mark. What's the question asking? Hopefully I'm pronouncing this right. Try tritium is a radioactive isotope. Wine may contain traces of tritanium. One 25-year-old bottle of wine was found to have an unusually high activity of 22 becquerels. The half of the tritium is about 12.5 years. Which of the following gives the activity of this wine when it was bottled? Now remember, read the question carefully. These multiple choice questions tend to, tend to give certain clues. So if you guys can see here, when it's written when it was bottled, it just means when the activity was when time was 0. Okay, so that's a clue word that's giving to you that you guys have to find the activity when time is 0. Okay, so now these are the formulas that you have to use to solve these type of questions. So in this formula, you have lambda is equivalent to ln2. I know many people pronounce it in different ways. They call it ln. Let's just use ln in this case. ln2. And by the way, this is like, I think it was logarithmics. Yeah. Divided by time. The half-life of the isotope, okay? You're going to use that formula first, and then because we need to find out what the decay constant is. And remember, the units are very important for these formulas. So you guys do have to know the units really well, okay? For decay constant, it's per second, okay? It's not seconds. Remember, it's per second, okay? You have to find lambda so that you can substitute it in order to find out what the activity was at time 0. But remember, it's not this part. It is the initial activity. You have to be really careful of how the wording is. Okay, so let's use the first formula here. So what I've done is I have substituted the time. We already given the time here as 12.5. You just sub it in because they're taking this in terms of years. So sub it in, you find out what lambda is, in this case the decay constant. Okay, sometimes it's not in seconds, it can be in different units, so you just need to check what the question is giving you. In this case, they're giving it in terms of years. Okay, so you have lambda, we have the value of lambda. All we need to do is now we have the value of lambda. Now we're going to take this equation over here and we're going to rearrange it. We're going to rearrange it to find what our initial activity is. Okay, I rearrange the formula so we get this one. On top of that, the question is giving you a high activity of 22 becquerels. So that's going to be your final activity. That's going to be this value of activity when it was at 25 years. Okay? So that's activity at 25 years. So if we're given the activity and we're given also the time that we can plug in. Remember, this time, that time is not the half-life. You got to be really careful with that. The half-life is this time of 12.5 years for that isotope, okay? Remember, the half-life is only for that isotope, nothing else, okay? Now, we know the value of A, it's 22 becquerels. We know the value of time, which is 25 years old in the question. And we know the value of lambda, which we have found using this equation over here, okay? All we need to do is just sub them in, sub it into your calculator, just substitute it right into your calculator, and you're going to find out the initial activity. So what I've done is I've subbed in all the values in, and you plug them in your calculator, and you should be getting 87.9 becquerels, which you can round it off to 88 becquerels, okay? So technically, this is just the activity that halves in each half-life period for that isotope. So that should be option C, all right? For 1 mark. All right, let's move on to the next multiple choice. Okay, this multiple choice, I've just written some of my reasoning here. Some of the reasoning for this question. Okay, so question 5. Okay, a fixed mass of an ideal gas has a volume V and exerts a pressure P. The absolute temperature of the gas is T. When the gas is heated, the new pressure is 4P. Which row of the table gives correct values of the new volume and new temperature? So now this is a question involving the ideal gas equation, which you can use as PV equals NKT. Now I'm just going to describe what these values stand for. P just stands for pressure. It's measured in pascals. V just stands for the volume, measured in meters cubed. N stands for the number of molecules. K stands for the Boltzmann constant, which will be given to you in your, I'm assuming in your formula sheet. It should be given to you the value. And T is just temperature in kelvins, okay? Now, you have another formula. Now, this one over here is for a change in a closed system. N's a constant, so PV by T is equivalent to the constant. That would be NK, I think, right? So remember that formula just for in a constant situation. Okay, so what do? We plug in the original values of V and P and then plug in the new pressure values. Okay, so what do? P times V divided by T. We have the new pressure, which is 4P, given to us in the question. We just sub it in. Volume stays the same for the other new one, okay? And the temperature, and remember, I think somewhere the volume should be halved. Okay, I'm just trying to figure that out. Why? Okay. So the volume V2 is given to you as volume, but it's probably because it's double. Now, the reasoning is because 4 divided by V2. Okay, what you're going to do is you're going to half the original volume. You're going to get it for V2. Okay. V by 2 because it's volume by half. And temperature, you're going to do it as 2T. So now what you're going to do is you're going to check whether these answers, if you plug them in, whether they give you a constant. Okay, this is very important. So you can check for each one of them if they do that. Okay, so so what we're going to do is we're going to plug in these values of V. For V2, we're going to plug in the values of V by 2. And for the new temperature, we're going to plug in the values of 2T. Okay, because we do know the new pressure, but they haven't given us the new volume and new temperature. So we're just going to sub it in. You guys can do it individually. So that's what we're doing here, okay? We're subbing that values for V2 and T2. We're just checking it out if it does give the constant, okay? Okay. So we subbed it in. We did some algebra, just do some algebra in this question. And you should be getting a constant, PV by T, PV by T. That's how we know that option A is the correct option choice in this question, okay? Because they must be equivalent to each other as we substitute these respective values for both volume and temperature, all right? Hopefully you guys understand that question. Let's move on to the next part. Okay, next question. Question number 6. Current theory suggests that the universe is expanding. Which of the following is evidence to support this theory? This is basically more like a memorization type question. Just know the theory, you should be fine. None of the 3 options tend to give all galaxies appear to be rotating in space. That's not a good enough explanation for this question. Dark matter has been detected in the universe. That's also not giving a good reasoning why the theory is suggesting that the universe is expanding. All distant stars are observed to be increasing in size. That still doesn't give a valid reasoning. We have to give the reasoning of the statement of Hubble's law. Hubble's law states that the further a galaxy is from Earth, the faster it recedes. So that's going to make it option D. That's going to be your correct answer in this case for 1 mark. Okay, let's move on to question number 7. Question number 7 is a student investigates the absorption of gamma radiation by lead. She determines the background radiation count rate before she starts the investigation. Now, which of the following would not affect her value for the background count rate? Okay, so now remember, read this question very carefully. Would not affect, okay, her background count rate. A place where she made the measurement. That really does affect the background count rate because the count rate can vary from place to place. Second part, the temperature of the surroundings. Now, temperature of the surroundings has nothing to do with the background count rate. So that makes option B correct. Now, why options C and D are not correct is option C is not correct because the time interval for the background count rate. The reasoning is because the background count rate is not constant. Type of radiation detector, some detectors are more sensitive than others. That has nothing to do with that. Okay, so actually that does have something to do with that. Both parts C and D can affect the background count rate. So sorry for saying that. The type of radiation detector does affect the background count rate because some, like explanation is saying, are more sensitive than the others. Temperature of surroundings has no effect on the background count rate. All right, let's move on to the next question. Next question is a formula-based question. Hopefully you guys can see the calculations here. I'll just be explaining it. Sirius and Alpha Centauri, they're two of our closest stars. Sirius has a luminosity of about 16 times greater than the luminosity of Alpha Centauri. Sirius is twice as far away from the Earth as Alpha Centauri. The intensity of light from Sirius is written IS, and the intensity of light from Alpha Centauri is I alpha. Which of the following is the value for IS divided by I alpha? Which is, the I just stands for intensity in this case. So we're going to use this formula. Remember, this formula, I think, should be in the formula sheet. Hopefully you guys have checked. Usually the formula sheets are on the back of the papers, so remember to check for those. Intensity here would be measured in watts per meter squared. Hopefully that's right. Luminosity of a star is in watts, and D just stands for the distance from the star in meters. This is a pure formula-based type question. So what we're going to do is just plug in the values. So now first we have to know the luminosity of Sirius. It's 16 times that of Alpha Centauri. So that's what you guys are going to do. We're going to write the luminosity of Sirius is equivalent to 16 times that of Alpha Centauri. Okay, that's what I've done here. And the distance of Sirius is also twice. Okay, so we do put that there twice. Now what we're doing is we're just plugging it into the formula. We're now calculating the intensity for Sirius. That's what we're doing right here. Okay, we plug in the values. We know the distance of Sirius and the distance of Alpha is not known. If Alpha Centauri is not known yet, but we can use that just get this ratio type value. Okay. All right. So now what you're going to do is you're going to divide, just as the question's stating. You just do some algebra math over here. Once you do that, you should be getting this. Yeah, over here. This calculation over here, that's what you should be getting. Now all you need to do is just plug in the values for distance of Sirius and the luminosity of Sirius. That's what's going to get you this. It's going to get you that, and then you can just cancel out some of the terms, which will lead to a math type number-based answer approach, which should give you the value of 4 when you do this rearrangement. So that will make it option B. Option B is going to be the correct answer in this case. Okay? All right, let's move on to the next question. Another theory-based question. The spectrum of electromagnetic radiation from a galaxy is observed to have a red shift. Which of the following is a correct statement about lines in the spectrum? Okay, part A is talking about all the lines are in the red spectrum, red part of the spectrum. Now, that is not a correct answer, okay, because the lines may be shifted into any region of the spectrum. Option B is correct in this case is because the lines are observed to have longer wavelengths than expected. That's what's expected from redshift. Part C and D are not correct. It's because part C, the intensity of lines is not related to the redshift. Part D is also not correct. It's because as the wavelengths of the emitted lines, they're not affected. Okay? All right, let's move on to the final multiple choice question. Remember, for the full life questions, okay? Yeah, so when we're solving the full life questions, yeah, that should be fine. Okay, question 10, what's it talking about? The graph shows how the binding energy per nucleon depends upon nucleon number for a range of naturally occurring nuclides. Now remember, this is just a paper walkthrough, so hopefully you guys are understanding some of these concepts. It's just mainly a walkthrough type video. So you guys can see that there's a graph on the y-axis. You guys can see there's a binding energy per nucleon. You have iron there at 56. That should be its mass number. Hopefully that's right. and on the x-axis you have nucleon number. Now, which of the following can be deduced from the graph? The iron readily undergoes fission. Nope, that's not right. Because Fe56 is the most stable isotope, fission releases less energy than fusion. Now, that's also not right because the graph shows the binding energy per nucleon. High mass nuclei cannot undergo fusion. That's also not right, is because high mass nuclei could be fused as long as energy is supplied. Now, that's a right statement to put there. Okay, that makes option D is the correct answer in this case because low mass nuclei release energy during fusion. Low mass nuclei release energy during fusion. Okay, this seems to be for about 10 marks. And yeah, hopefully you guys have understood how to do the multiple choice based questions. And total for these multiple choice questions would be 10 marks. And yeah, let's move on. Let's move on to the next part.